Yeah, we're going to give people a couple of minutes. So. So as soon as I recover my co-chair, we'll be starting. He should be back in 1 minute. Probably the queue to get coffee was a bit longer. I mean, he went to get coffee, so he will be here in like 1 second. Yeah, I mean, if you get to sign the blue sheets in the meantime, that'd be perfect. Yeah, thank you. Okay, we can get started. Then I'll go and find him if needed. Okay. Yeah. So get a seat and we can get started. And at some point, Daniel will be back. So welcome to the Trustworthy Multi-Purpose Remote ID BOF. As you know, this is officially it's a working group forming BOF, I guess, or working group rechartering. So the idea is that, if we agree to do this, we will talk to Eric and decide whether we want to recharter HIP or create a new working group or something, but that's not basically so important. So let's focus on, agreeing on a charter and having the discussions. The way we're going to run the session is like we will have 3 presentations, and we already talked to them, but we will try to limit somehow the each slot to 15 minutes, roughly, 15, 20 minutes, don't go over that. And after that, we will go into the Q&A and the discussions. If you have any clarifying questions during the presentations, feel free to go and ask. If you have more general discussion, let's hold until the end so that we can have the presentations, get you guys to be exposed to all the material they have prepared, and then just have the discussions afterwards. But if anything is like clarifying, something is unclear, just feel free to interrupt the speakers. Then at the end, Bob has put together a charter, because the idea of this type of BOF is to basically agree somewhat on a charter. So we will be projecting it at the end and thinking about that. And again, summarizing what are the main decision points here would be to agree if this is a problem, just so that I get you thinking about the questions that we will be asking at the end. If this problem is worth solving, if it's worth basically working on this problem, if the constraints that we're going to be defining make sense, and you will be the constraints basically defined, in the presentations, the scope, and then I will be asking the presenters also and the room if there's people that they are willing to put cycles on that. So we make sure that there's enough energy. That's one of the explicit questions we got from our AD. So I will be asking that. Okay, so now I got Daniel back, and we can start basically officially. The Notewell. So if you are not familiar with the Notewell, you should go off and read the Notewell and the links, the references. And this meeting is governed by the Notewell. And this is the agenda we put together. As I said, 3 speakers, roughly 15 minutes each, and then we will go into Q&A and discussions. Okay, so without further delay, we will go into the first deck. And as Bob was saying, please, stand close to the pink cross so that they can pick you up with the camera.
So first presenter.
You will go to full screen in a second.
Okay. Is that the 12th multipurpose? Is that this one?
Yeah, that one. Let's see.
Yeah, that's it. Hi, I'm Stu, and I'm a 20-some-odd year email list participant in some IETF activities, but a total noob for actually being here in person, so forgive me and correct me if I stray. So the subtitle here, Extending Locator Identifier Split and Strong Authentication Techniques to Identify Physically Nearby Objects, you'll notice that doesn't say anything at all about unmanned aircraft systems. Unmanned aircraft systems are the motivating first use case. But I mean, the general problem is I encounter this object in the physical world, and I have some reason for believing that it or a proxy for it is on the internet. How do I figure out which that it is so that I can begin communicating with it or its proxy or whatever? So talk about the UAS problem. We need to somehow identify these aircraft. They're small. They're not fast compared to a jet airplane, but they're fast compared to how big they are. And they're fast compared to the distances at which you can see them, hear them, receive short wavelength radio transmissions from them, etc., which means they can close the distance to you really rapidly. From the first point where an audio-based detection system for drones can detect a drone and it's been optimized to be able to hear it at range, until when it's on you is a matter of maybe 15 seconds if it's flying full out. So if somebody is malicious, this is clearly a problem. Or if somebody is merely incompetent, it's a problem. The language that's developed in the industry to talk about the operators is the clueless, the careless, and the criminal, right? The clueless guy doesn't know that he shouldn't be flying at Gatwick. The careless guy knows that he shouldn't be flying at Gatwick, but he doesn't care. He figures, who's going to notice? I'll get away with it. And then the criminal guy, he's there because he intends to do harm. The criminal guy, I believe, I still have enough faith in human nature, is in the vast minority. But even if he didn't exist, we got a problem with the clueless and the careless. Remote operation. Everybody's used to the little joystick controller for the guy who's flying in the park. But, we've slapped LTE modems on these things, which, by the way, is mostly illegal. And at that point, you can fly them 12,000 miles away. So this talk will be a little bit United States centric because, those are the people who are paying me to do this work, and that's what I'm most familiar with. But the FAA in the U.S. is just one example of a civil aviation authority, and all the CAAs worldwide are worrying about this problem. FAA is going to do a notice of proposed rulemaking this December. They want to do performance-based standards. They've turned to ASTM International as a consensus-based industry standards development organization to develop how this will be done. I was at the ASTM meeting 2 weeks ago where we passed a standard that doesn't answer the mail. It is cool so far as it goes. It's got 2 modes of operation. Network remote ID uses the internet to get information from the aircraft or a proxy for the aircraft, which might just be the operator's cell phone where he goes to a web-based form and says, I'm going to operate in this airspace volume from this time hack to that time hack. But somehow over the internet, I can find out who's in this airspace volume at a particular time. Broadcast remote ID is an actual transmission from the aircraft to the ground, so I can take my phone or my tablet and receive it and get a beacon from this thing. Who is it? But the initial ASTM standard falls woefully short in making the information immediately actionable. First off, I can just assert, I am Adam's drone. There's no signature, there's no verification, there's no basis for trust whatsoever in the ASTM standard. They do have a so-called authentication message format, but it doesn't really tell you how to do authentication, which is kind of cool because that gives us a foot in the door, right? It gives the IETF an opportunity to write some complementary standards based upon the much greater knowledge of cryptographic protocols here in this SDO than in that SDO, which is more concerned with strength of materials, to solve this problem. Secondly, there's no way to know whether the operator is trusted if the observer lacks internet connectivity. I got this ID, I'm looking at it, I go, okay, it's drone number 12345. Is that a guy who's well-trained and is allowed to be flying near the nuclear reactor to make sure that it's not leaking? Or is that some hobbyist who's flying near the nuclear reactor just because he thinks it's fun? Also, there's no way to instantly communicate with the operator and say, I need to get this guy to exit this airspace volume or land right now. I need to communicate with him immediately. It's not built in. So anyway, the problem comes from the fact that aviators tend to be familiar with radio comms, but not with the middle layers of networking. So IETF could bring a lot to bear here. We think that HIP can help, DNS can help. The whole registry process, probably with RDAP rather than WHOIS, could help. We need to strengthen authentication, but also balance operator privacy, right? You don't want the little old lady next door who hears the buzzing sound and doesn't like it to have remote ID as a way of identifying and harassing an operator who's doing something that's perfectly legal and legitimate. But when a public safety or security person needs to identify that operator and talk to them and say, you got to land, then there needs to be a way to present credentials, to RDAP, for instance, and then pull that information that makes that possible. We think it can be generalized to support lots of other applications. And fundamentally, we think that this mapping of an unmanned aircraft's physical location to an unmanned aircraft's identity is kind of isomorphic to an inverse problem of a host's logical location in the internet, an IP address, to a host ID, which is why we've done some work with HIP. We have actually prototyped and flown a HIP-based extension to the Open Drone ID at the New York State UAS test site. So I'm going to go a lot quicker on the remaining slides. How much time have I already burned? Really? Oh, thank you. Okay. Anyway, so obviously remote ID is critical for unmanned aerial system traffic management. You see it, you want to know who it is. From that, you can look up all kinds of other stuff. Lots of different entities need it for lots of different reasons. The first question is, can I ID this guy? If I can't ID him, then unidentified is an important attribute that might go into further decisions. If I can't ID him, is he taskable? Can I ask him to go over there and take video for me to a better look of the building on fire? Or is he just of low concern because I can't task him, but I can at least ask him to be cooperative from a safety perspective? Or is he an aircraft of high concern? I mean, maybe he's the one who set the building on fire. The ASTM standard uses various internet media to do remote ID, typically would be LTE. There's a network grid service provider that gathers data from all the sources, and then there's a network grid display provider that is where you point your web browser to if you want to find out who's flying in this airspace volume right now. They can be co-located or not. They can be the same corporate entity running them or not. And a so-called UAS service supplier, which is a big part of this new UTM UAS traffic management system, it does other jobs, but it's going to do this job as well. Broadcast remote ID is a much harder problem. They started out with the idea that your average volunteer fireman needs to be able to go to a scene and see an aircraft and be able to identify it, which means we're not going to equip him with a special radio or whatever. He's got a phone, which meant they decided that we got to be able to do this with Wi-Fi neighbor awareness networking and Bluetooth 5, and to my chagrin, also with Bluetooth 4. Which really constrains the physical range and the packet size. So we're just using the beacons, basically. So we can extend this once you've got ID to vehicle to vehicle, vehicle to infrastructure, et cetera. Can be used to keep these things separated, safe distances, and we can even support payload comms. And we've experimented with a lot of this at the UAS test site. Internet protocols have got a lot of issues when you try to use them for airborne comms. And, but fortunately, we're likely to have multiple radios if it's a big aircraft. And so we can take advantage of having those multiple radios, but each of those radios has got lots of link layer issues. Cryptographic handshakes are a big problem because you got little processors, not much processing power, and two aircraft that pass in the night have got a very brief radio contact window to do these handshakes before they move their actual traffic. And then you've got the whole aggregating information. If Amazon can watch Walmart's delivery drones and vice versa, then they can infer things about their businesses. So the first mitigation that we've applied for command and control is just to take advantage of multiple wireless links. That brings a lot of benefits. All these slides are available, so I'm not going to waste a lot of time on each of them. Second mitigation is strong identity-based security. Now, a big aircraft has a tail number on it. You look at it sitting there on the runway, and it says, N12345 on the back of the aircraft. Problem is, if the aircraft is this big and it's a few hundred feet away, you can't read that number. Plus, they're allowed to put it inside the battery compartment. Obviously, an aircraft's tail number doesn't change when it hands off from base station to base station to base station. Its IP address does. So this is one of the things that drove us to HIP. We'll come back to HIP more later. For right now, I just want to say that HIP buys us a lot of things for this application. So this is an aerial shot of where we do some of this test work at the New York UAS test site. We've actually maintained positive command and control using HIP, where you flew outside a Wi-Fi range, you just rolled over to LTE, you got back within Wi-Fi range, you rolled back over to Wi-Fi. Remote pilot never even knew the difference. Our approach to unmanned aerial system remote ID is to adopt and extend existing standards, and there's a whole boatload of different standard-setting bodies involved. The International Civil Aviation Organization, the Radio Technical Commission for Aviation, the various civil aviation authorities, including here in the we're not here, including where I live in the United States, the FAA. The FAA has said that they're going to cite this ASTM. Well, it was draft when I created this slide. Now it's a standard as of 2 weeks ago. But security and the threat model are simply not addressed in the draft. So I've made myself very unpopular in ASTM by saying, hey, you need to bring in the IETF here because these guys understand how to do cryptographic protocols, which ASTM, that's not really one of their strengths. So again, the forward problem of host ID to logical location is similar to the inverse problem of mapping physical location to a UAS ID. So we think we could use HIP and some other IETF standardized protocols as adjuncts to the ASTM standard. If the observer has got internet connectivity and the pilot has got internet connectivity, then we could do a one button, I need to talk to the pilot right now. And if the observer doesn't have internet connectivity, but he's got a database on his device, not of all the aircraft, but of all the registries, then with an extension to HIP that Bob is proposing, hierarchical host identity tags, I don't know Adam, but I know that Adam is in, I don't know, the Department of Homeland Security's registry. And because he's in DHS's registry, I can say, yes, Adam is allowed to fly at this emergency site, unlike the hobbyist who's in the registry that's used by everybody who buys their drone at Walmart. I think this is it for my first, here's the last slide for my first part of the deck. Over on the left, we've got the case where there is internet connectivity. So the observer sees the aircraft, he receives his Bluetooth broadcast with remote ID, he does some lookups, he figures out who this guy is, he presses the button that says, hey, Mr. Pilot, even though it was entirely legitimate for you to fly in this airspace at the time you filed your flight plan, well, now there's a building on fire underneath that airspace. Please get out. And then this second case here over on the right, the observer doesn't have internet connectivity, but he does have this database of registries, and he can see that this guy is not in a registry of trusted operators. So at a minimum, although he may not be able to communicate with the pilot, he at least knows that this is an aircraft of concern, that he's going to have to do whatever it is he does. So let me take a look at the next slide just in case. Okay, so I guess I should wrap up with this slide. My two keywords are UAS remote ID information must be immediately actionable. I've got to be able to trust that it's real, not that it's being spoofed. If there's any way to have communications with the guy who can land that aircraft or exit this airspace volume, I want to be able to do that instantly, not by looking at a screen, calling a phone number. The guy doesn't answer the phone because he's flying a plane, right? And we want to know whether the operator is trusted, and yet somehow we've got to maintain privacy when it hasn't been forfeited by a clueless, careless, or criminal action. And we believe that there are several protocols within IETF land that can complement the ASTM stuff to make this happen. Standards in ASTM are going to need two minor tweaks. There's a UAS remote ID type. It is either type 1, a manufacturer serial number when the thing came from the factory, or type 2, a number that was assigned by the FAA or other civil aviation authority in whatever jurisdiction you're in. Static, okay, enabling correlation attacks. Or 3, it's a UTM assigned ID, which in principle could be dynamic, but all of them today are static. We want them to assign type 4, probably a hierarchical host identity tag. That's our going in position. Now, people here in the room know an awful lot about an awful lot of other protocols that may bring something to help solve this problem. All I've been able to find that's able to fit in these little tiny Bluetooth packets and provide the trust properties that we need is HIP. But there may be things besides HIP that could help. The other tweak we need is there's just a parameter that's 5 and it needs to be 10 in terms of how many segments a message can be segmented into, and that'll make it big enough that we can put a really, really short host identity tag certificate of which registry you're registered into one of these short messages. We're going to need more work on the IETF side. We need to bring more modern crypto to HIP, which Bob will talk about. We need to have hierarchical host identity tags in HIP, which Bob will talk about. And we need to look at what we can do in DNS for stuff that any member of the public should be able to look up, and what we could do in the registry system with RDAP for things that only duly constituted authority can look up when they present their credentials. That's my time. Thanks.
Take your time.
Actually, I was done.
That was
Lucked out.
yeah. Eric.
Eric Nordmark. So you said you made yourself unpopular by pointing out that they need some help. Have they gotten to the point that they would appreciate help from the IETF at this point, or not?
There is one chairman who remains to be convinced, but those who actually produced the standard that was just approved, they appreciate it. When they started trying to add trust, I mean, they didn't take a going in position of, we're just going to assert claims and they are what they are. They wanted to have this thing trustworthy, but they just couldn't figure out how to make signatures short enough and how to make certificates short enough that would fit in these tiny little Bluetooth 4 payloads. And when we came to them and said, yeah, we can get that done, they're like, we're thrilled, but why didn't you come to the party 6 months earlier? So that could have been in version 1 of the standard.
Thank you.
Barbara Stark, AT&T. This sounds pretty rational, but I'm curious, you didn't list CTA, which is another player in this, and they a couple of years ago now, I guess, did a thing on identifying the syntax of an ID. And then they tried to start getting into this, and it was really horrible. Unfortunately, it died. Are you would you be liaising with CTA as well, just to make sure that things don't get, and GSMA, and it's like, it's more than just the ones you listed. Would liaising be a lot of what you intend to do? And I would hope to see it in the charter.
Yes, liaison is going to be a key piece. I don't have standing in the vast majority of these organizations, but for instance, Ray Young, who's here, he has long been involved in the aviation industry, and so he's plugged into several of those. Bob obviously is well plugged in here, and we're going to need to recruit people who are plugged into these other SDOs so that we can do that.
Okay.
Wes Herdeker, ISI. They seem to have this belief that trust is binary, and that authorization is easy, and that authorization will never be misused. What's the clue level there?
So I hope I didn't give the impression of thinking that trust was binary personally. I got a little bit more nuanced view than that. But really what we're looking for in terms of trust is most fundamentally that there is some evidence that the asserted ID of this aircraft or of this aircraft's operator is indeed the ID of that aircraft or its operator. Then once you start getting into what is the information that's in the registry and has that information been vetted and all kinds of other, second order issues like that, we'll kind of cross that bridge when we come to it. But right now it's just that the ASTM standard, I can assert I am Adam's drone and that's it. We're done. And we want to at least have something where when I make that assertion, I can sign that assertion with something where you can verify that signature. That's like the first step.
I'm Ray Young, and I represent the New York UAS test site, which is one of 7 test sites in the United States designated by the Federal Aviation Administration to test unmanned aircraft systems. I'm also a member of the ASTM F-38 group, and I've been working with RTCA, which is the Radio Technical Commission for Aeronautics, on unmanned aircraft standards since 2011. And the answer is to whether ASTM is seeking help from IETF is yes. The problem with the current ASTM standard, which we call version for remote ID version 1.0, is it's not scalable and it's not secure. So we've already, at the meeting 2 weeks ago, which Stuart attended, we are under great pressure to get out a remote ID standard from the FAA, because the FAA will not allow drones to fly over people or over crowds or beyond line of sight, visual line of sight of the pilot without a remote ID standard. So the version 1.0 that we approved, we had to deal with some objections, which was a difficult process, but we finally got the version 1.0 standard out just to get something that people could work with. We're committed to working on version 1.1, which hopefully will include host identity protocol, and we're already planning on version 2.0, which will incorporate higher standards of cybersecurity when the final rule is approved by the FAA. So this is very logical. We're excited about the work that this team has done. We want to see it move forward.
Thank you. Juan Carlos?
Yes. Sorry, Juan Carlos Zúñiga. I'm with Sigfox, and I also happen to be a regular attendee of IEEE 802. And I was involved in the past in the work on the Wi-Fi MAC address randomization for privacy issues. So I'm familiar with the way registries addresses work. And so to me that some of the requirements I saw, especially talking about Bluetooth and stuff, rely on identifiers that are basically managed by registration authorities like the IEEE. And if that is a requirement, that means, or at least my understanding is, we cannot change that. So we have to rely on existing identifiers that are on those, hopefully, compliant drones. So if that is the case, then correct me if I'm wrong, but I see the problem as 3 issues. One is the identifier itself and being an authentic identifier. The second one is getting that identifier to the actual person that is concerned. And the third one is that person authenticating the identifier. So am I right saying that we only want to concentrate here on the third problem?
I'm not convinced that the MAC will be a panacea because, for instance, it's frequently randomized for good reason. I guess we can talk in greater specifics later. I'm really hoping that people will step forward with alternative solutions besides the HIP approach that we have prototyped.
Okay.
But it seemed to me that a hit was the most suitable identifier of the various identifier options of which I was aware.
Okay, so.
Bob Moskowitz, HG Consulting. Just to on Carl's comment about MAC address registration, my work with some of the processors which are used in these devices is that they use a local scope MAC address for both their Wi-Fi and their Ethernet. They do not use a registered one. That MAC address is derived from a device number buried inside that particular chip. So each chip does get a typically a different address, MAC address assigned, so they can exist on the same physical media, but these are addresses that do not go through the IEEE registration process. And I don't know what they're doing for the Bluetooth. I can't speak to that, but I can speak to the chip's use of Wi-Fi, and they also tend to have Ethernet for configuring them when they're on the ground.
Andrew McGregor, Fastly. I also happened to, in a previous situation, be involved with a search and rescue drone operation for New Zealand's Coast Guard. We had the somewhat unique distinction of actually getting certification to fly a UAV at night in controlled airspace under IFR conditions, because we had a particular problem, which is that there is a known marine trouble spot that happens to be dead center on Christchurch International Airport's runway 20 approach, right about at the middle marker. And we needed to be able to operate UASs over that. So we got quite a bit of experience at talking to New Zealand CAA about these kinds of issues. And all of this stuff, firstly, I was well aware of it because I've been involved with it way back at the beginning. We actually discussed a solution very much like this with Airways New Zealand and the NZCAA, and I'm certain they would be very glad to see this happen. It would solve a lot of people's problems. We actually got that done by maintaining aviation radio and cell phone contact with air traffic control the whole time we were doing it, which is one option for a search and rescue organization. But that doesn't work in a situation where you don't have radio comms. That doesn't work in a whole lot of places. And one of the things about this that occurs to me is that there are going to be manned aircraft running in the existing air traffic control system that also need to run in this system simultaneously. Particularly rescue helicopters and other SAR aircraft, but there are police and various others are going to do it as well, for sure, because they're going to be working in conjunction with drones. And so that interface is something that needs to be sorted out and get its regulations sorted and so forth. I'm going to try and get in contact with some people in New Zealand and plug them into this process as well, because internationally that particular civil aviation authority is very influential. Their control zone is a sixth of the planet. It's bigger than the FAA's, and they run, I think, 4 other countries' civil aviation organizations as well, because they're just that good at it. So I'll yes, plug some people into the process.
Thank you, Andrew.
Thank you. And to just speak to that issue of the interface between manned aviation and the ATM system and unmanned aviation, the UTM system, the general scheme is that it's the small unmanned aircraft operator's job to stay out of the way of the larger manned aircraft. So the larger manned aircraft are typically beaconing automatic dependent surveillance mode B, ADS-B, and so long as that information gets pumped into the UTM system, then the operators of these small craft can stay out of the way of the big aircraft. The big aircraft don't need to and don't want to keep track of where all the little ones are. But that said, an interesting thing that seems to be gathering steam is that because UAS typically don't carry human passengers who can die if they crash, they're being held to a lower safety standard than manned aircraft. That's both good and bad. The good part is that it's allowing for a lot more experimentation. And so the tech is advancing in the unmanned aircraft world much faster than it's advancing in the manned aircraft world. And eventually, I've heard people say UTM is the future of ATM. That we're going to sort things out with these small unmanned aircraft, and then it's going to migrate its way up into larger manned aircraft as well.
Rick Taylor, Airbus. So one of the considerations, and I totally appreciate, and this is not my area of expertise, one of the considerations when you talk about moving technology onto aircraft which carry passengers, as you say, the reliability aspect is massively increased. So you're looking at real-time embedded operating systems. Sorry, my my voice is going. RTOS, reliability, stuff done in firmware, stuff done in triplicate with different compute systems. The solution must be bulletproof. So a lot of internet-style technologies don't go on the flight deck, you'll be pleased to know. So there has to be that consideration in there when you're talking with civilian aircraft.
All I can say to that is point well taken and underlined.
Andrew McGregor again. I'd like to point out that your major competitor is also the only organization that has they and their customers are the only organizations that have a significant scale deployment of HIP. Every Boeing customer and supplier is using the protocol, whether they know it or not.
Yeah, the death of HIP has been greatly exaggerated, although the deployments have been quiet.
Okay, good. Moving on.
Okay, so I think I'm supposed to do a few more slides now on the next topic, right? Oh, I'm sorry.
Go ahead in the meantime.
Pardon me. This is possibly off topic, and I apologize for that. My name is Mike Hoy with Mozilla, and the concern I have was about the degree to which this respects privacy, particularly because we've talked about this technology scaling upwards to much bigger hardware, but it's certainly I can certainly envision a world where it scales much downward towards commodity hardware of any type at all. Right, the ability for the authorities to reliably identify a specific piece of hardware in a specific location is, to the wrong kind of authorities, an extraordinarily valuable resource. And I'd like to hear more about what you envision robust privacy concerns there to look like, particularly given that the model you've described involves, very rapidly delivering and acting on very accurate information.
So I don't want to prejudice the work of what will hopefully be either a Tmrid working group or the HIP working group. I can only give you my going in intuition, which is that HIP can give us an identifier. DNS can allow us to look up very rapidly that information which has few privacy implications and that any member of the general public at any time ought to be able to look up. And then something like, just inspired by perhaps the business models of the domain registries, but not with the WHOIS protocol with its known issues, something more like RDAP, where access controls can be there and you can ensure that policy is satisfied before the information is revealed. Now, that assumes that there is some probably governmental authority that in any given jurisdiction says this is the information that you must put in the registry and that we must be able to look up or you don't get to fly in our jurisdiction. And I'm afraid that goes beyond anything to which I can find a solution if the particular jurisdiction is totalitarian.
At least with regard to unmanned aircraft and privacy of information. Be aware, Stu has not said this, the law states that the FAA controls all navigable airspace in the U.S. And so whether that's 1 inch above the ground up to the top of the mesosphere or 3 feet above the ground to the top of the mesosphere is something we can discuss. You do not own your backyard. You do not own your roof. The FAA, in a sense, does. In terms of your right to privacy, to a certain extent to whom is you are in a public domain and there's certain privacy that you forfeit by being in that. Yes, once this goes to other areas and other things, who then has access to the additional information, that will be a policy set by that user community. The intent here is that there will be an authentication basis in terms of who can get what sort of additional information, but this is a safety concern of the open airspace, which is a rather unique situation that many people, even the people who operate in this with their hobbyist drones, don't understand what it is they're doing. We had the case in Texas where the man shot down a drone over his backyard. He was indeed found guilty, but since there was no existing law, he was fined $1. But it again sets a legal precedence that no, this is an open public space.
Yeah, it's kind of like the story about, the right to shout fire in a crowded theater. If I'm in a theater and I'm minding my own business, watching the movie and eating my popcorn, the guy in the seat next to me has no business knowing who I am or what credentials I possess, right? But the minute I shout fire in that crowded theater, I have forfeited my right to privacy. So the clueless, careless, and criminal operation of a vehicle in airspace forfeits some degree of privacy. But up until that point, the privacy should be maintained.
Jonathan Hoyland's Cloudflare. Just to push back a little bit on that, we're talking about a broadcast medium that is permanently broadcasting. So we're already assuming that even if you may legally have no right to privacy, that nobody in any country ever would ever want privacy, which is sort of, the privacy aspect should definitely be in the protocol from the beginning. Even if you don't necessarily have a legal right to privacy, you might still want it. Secondly, the record keeping of who has looked up, i.e. the authentication of the requester of this information, is, also very important and hasn't really appeared in the slides so far.
Correct. And I'll go one step further. What if I observe your aircraft in a particular place at a particular time with my device, and I record the beacons that you have broadcast? And then I subsequently assert in front of a magistrate that I received those beacons at a different place or at a different time. You may have been flying in an entirely legitimate temporospatial volume, and I assert that you were flying in an entirely different volume. We have looked at the need for a fair witness on the observer device such that the logged information received over the beacon is trustworthy. Not just that it was trustworthy coming from the aircraft to the observer device, but that the observer cannot easily falsify where and when this guy was flying.
Thank you.
Rick Taylor again. I think Mike has a very valid point, which is, I understand that this is largely being funded out of the US, and the US has a single, fairly open legal system, but the IETF is not a US organization, and the FAA will lead the way on this, and whatever the IETF works on has to be applicable in jurisdictions outside of the West, in quotes, into some other places in the world where they will just pick up and run with this technology. The manufacturers are not largely US. So privacy is a concern here beyond what is expected in a Texas backyard.
Granted, but to allay some concern, the FAA's UAS Remote Identification Aviation Rulemaking Committee, ARC, in their final report of recommendations in the fall of 2017, devoted a considerable number of pages to the protection of personally identifiable information, which is not something that you might have expected from a regulatory agency.
Stay tuned to later slides. The intent here is that what will be broadcast is that, hello, I'm Doug the drone, and you always know that I'm Doug the drone, but that's all you will know and nothing else from the broadcast. And to be shown.
Eric Nordmark, I want to sort of reflect on this in a second, and then we can move on, but I'm delighted that in the first 40 minutes of a BOF that talks about this stuff, we've spent 20 minutes talking about privacy, because I've never seen that before, right? It's clearly important, and this is something that presumably a working group will actually spend time working on based on what I hear people saying, right? So that this is great.
So I think I need to move on to my second briefing, which will be shorter than my first one. So the first briefing was really intended to convince anyone who needed convincing that the problem of unmanned aircraft system remote identification is an important problem, and that the IETF can help. And that was the whole point, right? The point of the second briefing is that although I was not one of the original HIP developers, I have been a HIP true believer for many years. I have several small deployments, and maybe it's because all I have is a hammer. This looks to me like a nail, but maybe HIP really is a good match for this application. And so I'll just give a couple of slides to why I think that's true.
JavaScript interrupt, sorry. So Greg Deeds has posted in the Java chat saying, I'm one of the authors of ASTM Remote ID Standard. I don't recall this, we're talking about privacy, being widely considered at the meeting. This is not a consensus model being discussed by ICAO. IETF support effort is early. There are other options IETF can offer via OAuth 2. We need OAuth to be fixed and it can roll in HIT. ICAO trust frameworks is not considering this for integration with large aircraft, which is needed for UTM to be accepted worldwide. It goes on. But yeah, I feel like I got the gist of.
All true. Summary response, I was late to the party. Okay. ICAO has been working on this for a while. ASTM's been working on this for a while. I was woefully ignorant of those efforts until quite recently. And they have problems that they didn't think could be solved. And I said, hey, wait a minute, over here in IETF, there are solutions that could be applied. And they're like, we don't believe you. This is too hard. There you go.
Sorry, just to read off the key bit of the message. I suggest we hold off until next year to allow for Airbus, Boeing, and others to contribute to the conversation.
I guess I have to disagree because this is moving so fast. The FAA is going to issue their notice of proposed rulemaking in December. It's already been delayed repeatedly for something on the order of a year. And if we don't bring forward the solutions, including the privacy protections that the IETF can offer now, we're going to be stuck with something, and it's going to be an ugly baby.
Andrew McGregor, I'd also like to point out that the IETF's lead time is not trivial. So, so even if the IETF does this at IETF and fast mode speed, holding off for that effectively amounts to holding off for a year in itself.
Thank you.
Okay, so if you're not familiar with HIP, RFC 4423 lays out the architecture. There is a current draft for RFC 4423 bis. The only reason that draft has not proceeded is it refers to a couple of other drafts that have some issues, so they have not yet proceeded, so it's just a dependency issue. The overlay routable cryptographic hash identity, which is what a host identity tag is defined in 7343. 7401 is the basic HIP standard. 8002 through 8005 are various extensions, some of which, even though they are considered extensions, are pretty fundamental. The general thing that HIP does for us in remote ID is it gives each device a persistent identifier that remains the same across IP address changes. So just like the tail number of the aircraft doesn't change, the HIP host identity doesn't change. The big beauty of this is it enables persistent TCP connections, just like mobile IP. I was an early deployer of mobile IP to aircraft, and then when HIP came along, I'm like, ooh, better. So security associations can be persistent as well. It gives all packets a provenance. There is a book, Beyond HIP, The End to Hacking as We Know It, which an awful lot of is marketing glitz, but it does drive home the point that every packet has a provenance, and that can be a handy thing. It can also be a very dangerous thing when we go back to the privacy issues. Boeing already using it in the secure mobile architecture and derivatives thereof. It's a natural match to aeronautical networking, where you associate the persistent identifier with the aircraft tail number. Now, it's not really called a tail number for small UAS. It's called something else. Just like it's not called a flight plan, it's called an operation or whatever. And then multi-homing is really, really helpful because we can do make before break smooth handoff. You really don't want a lapse in connectivity when you're doing remote ID or command and control or various other things. So network remote ID can leverage all of HIP's advantages. So it's not just that we can have a host identity on the aircraft. We can have a host identity on the UTM service supplier, the USS. We can have a host identity on the registry hosts that you're turning to. So, I don't know how far we want to take this. And one of the beauties of HIP is automagical setup of IP security ESP tunnels from the observer to a pilot. So I can say, I need to talk to this guy right now, and I want that connection to be mutually authenticated and strongly encrypted. Broadcast remote ID is much more constrained, but we can still have a verifiable, persistent ID if it is specifically a hierarchical hit. Well, the second bullet is really if it's a hierarchical hit. Which registry are you in? You're in the good guy registry or you're not in the good guy registry. And obviously, good guy registry is in the eye of the beholder. And then beyond HIP, right, I think there's a lot of other machinery that the IETF can bring to bear, including DNS and RDAP as a start. And a radical idea that I want to propose is multicast HIP, because sometimes what I want to do as a public safety person is contact all the operators of all the vehicles that are currently operating in this airspace and say, full stop, get out, or land, or whatever, right? And multicast would be very, very handy for that. I think this is the last of mine. Yeah. Thank you.
Yeah, thanks. So Adam, or you want? We said first Adam, then I think. Yeah. So I think, I mean, we had good discussions. I didn't cut them because I think it's important to understand what is the use case. Now we will dig a bit on the details and how they have been approaching this problem.
Hey everyone. So Adam Whitaker. I work for AX Enterprise. I've been working on this for maybe about 8 months now, maybe 12 months, and I've been focusing on authentication message formats. So I'm going to go into a little bit of detail, technical detail here, just to give you some scope of what we're dealing with. Okay. So obviously, Stu brought up the ASTM standard. I passed the bell on November 7th. Everything's great. So there's an authentication message. So there's a bunch of different message formats in the standard. One of them that we were focusing on is the authentication message format, and it's a paged format. So it has up to 5 pages. This is the thing Stu was mentioning, that we need the number to go from 5 to 10. And you can see a very general outline of how this looks in the packet format in a Bluetooth packet. So you only hit 109 bytes of payload for authentication, be it a signature, be it a certificate, whatever. And this line, authentication data signature, is exactly what the ASTM standard says. They don't specify anything beyond what you see here. And this is a very stripped out version of it. So I'm going to give you a little bit of background on Bluetooth. So what you see to your right is the Bluetooth packet format. There's 19 bytes of header. There's 25 bytes for the message. That's it. We have 25 bytes in a singular Bluetooth message, whether it's Bluetooth 4 or Bluetooth 5, well, mostly Bluetooth 4. And this is all we have. And this is where our constraint is. So that's where we're fighting. So we have a couple different solutions that we've been thinking of and been trying to prototype. The first was a authentication wrapper. So in the Open Drone ID message, the 25 bytes, we would include the hierarchical host identity tag, a timestamp for trust, the signature, and the payload. Now, this is based on some stuff that Bob will talk about with the new crypto, but the hit is 16 bytes long. The signature is 32 bytes long, and that's or 64. Sorry, nah, I get my numbers all screwed up. And you only get 23 bytes of payload. So this is the first wrapper format that we kind of came up with. We looked at the constraint size and we said, what can we fit that's meaningful to us? The payload has to have some sort of dynamic thing if we want to sign. That's why there's a timestamp that we have there. But it could be any message. Conveniently, the payload is just big enough to fit any other message format from the ASTM, because they're all 24 to 25 bytes long. So we could just fit them in. So how we got up with this, I'm sorry if this is a little too small, but the slides are available. We came up with a trusted vector or trusted message format where you put in the payload, as you can see here on the far right, a vector message. And now the vector message is signed. You can sign the vector message and assert its trustworthiness. So on the RID application, you might see vector dots every second. Blink, 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 blink. But every third one will turn yellow because of this format, where we resend a vector message almost instantaneously to assert and sign, yeah, this is where I'm going and this is my path. So currently we only have the send side prototyped. We're working on the receive side, and that was part of my hackathon thing. I'm still working on it. So hopefully I'll get something by the end of the week, maybe. We'll see about it. The other thing that we came up with was signed hashed lists. This is an invention of Stu's. I did not think of this. I'm just implementing it, and I'm trying to make sense of it still. So basically, we want to try to provide provenance to the messages. You're spitting out on Bluetooth messages every second, at least. That's a lot of messages, and you might not trust all of them. So what if you could hash them, bundle them up in a little package, and ship them? So these are two variants on message signing, message hashing, and then signing a list of those hashes to help out there. You might notice that I say pseudo blockchain. Blockchain is a nice word that we use a lot, and it kind of annoys me. But if you could link these authentication messages, these signed hashed list authentication messages together, and you trailed a drone somehow, you could, in theory, re-put back together the entire flight path. But the question that I have, and I'm still working on, is this really worth it based on the number of hashes we have? As you can probably see here, there's only 7 message hashes in the left one, and there's only 5 message hashes in the right one. If this is only being sent out once every 3 seconds, is it worth it? I don't know. So that's an open question. The final authentication message format that we've been tinkering with, thank you to Bob, is the offline based. So Stu was mentioning, whether you're online or you're offline. This is your offline, where if you get the idea of a drone and you don't have internet connectivity, you can still at least trust it because you have the registry, the auth in this case, side, where you can look at the registry's hit and you can look at its signature and be like, yeah, I trust him because he's in a registry that I trust. I'm in the DHS registry. That drone's in the DHS registry. Well, he's flying over an Air Force base. I guess this kind of makes sense. So this is this. However, this does not fit. The authentication message format is only 5 pages long. So the max is 109 bytes. You need a minimum of 200 bytes to get this to fit. If someone has some other way to do this thing in 109 bytes, I'm curious. But that's one of the pushes we're going for ASTM, is to go from 5 pages to 10 pages to make this thing possible and not fragment it as badly as we want. So future work, we need to talk to the ASTM on 5 to 10 pages. This entire formatting stuff that I just went over might get pulled into the ASTM instead. But that won't happen tomorrow. It won't happen next month. It'll happen a year from now in version 2, most likely. So I'd love feedback. I'd love comments and, hey, maybe this kind of format would look better. To have a list of things that we could bring to the ASTM to be like, look, this might be useful. Might be worth it. If you don't mind, let me finish this slide real quick. So improvements to the format, as I said. I need some stuff to do on my draft, missing pros and stuff like that, and development of prototypes to show that this is actually viable and works. Go ahead.
Thank you. Juan Carlos Zúñiga again. Thanks a lot for information. I'm just curious, trying to figure out how, in your mind, this should work. Okay. Because we keep talking about backwards compatibility and the Bluetooth thing. So Bluetooth has this advertising services, right?
Yes.
So they have to say, I'm a thermometer, I'm a audio device. So I guess you are relying on some existing service of Bluetooth that potentially will be broadcast by hundreds of devices in the exact same area. And you have to figure out which one of these 100 beacons is actually the drone, then look into the payload, then figure out if there's a open drone ID message, and then go and query the device. Yes. So
yeah, there's a lot of layers to this.
Yes.
It's quite complicated, let's be honest. So I really don't know how to phrase this properly. The Bluetooth format is dumb. Let's be honest. I mean, you can see it here. I only get 25 bytes. That's and that's where we fit. And the ASTM standard breaks this further down. Actually, let me jump to, I will come back to that. I'll jump to this slide because this is one of my beautiful backup slides. You can kind of see where the ASTM, there's a header in the ASTM so that you can find out what message they have. But at the end of the day, we're just using their beaconing, Bluetooth beaconing frames. That's the technology we're using, whether it's in Bluetooth 4 or Bluetooth 5.
But the beacon does say with the type of service the device is supposed to
Yes.
do, no?
Okay. So, do I have that slide here? I do not have it here. So in the Bluetooth, at the very end of the Bluetooth frame of the Bluetooth headers, there is a application code.
Right.
And the ASTM has gotten approved an application code. It's 0D. That's their application code. So
So that will be
that's
backwards compatible to Bluetooth 4.
Yes. It should be, yes. I don't know the exact answer. I'd have to look at it and then get back to you.
So just a clarification, Juan Carlos, was your concern about the allocation of a code point or the complexity of the Bluetooth protocol itself?
That's kind of.
I'm just trying to figure out how complex the problem is and how much can we actually do at higher layers when probably the bigger issue is in the lower layers.
Okay, right.
The interesting, Bob Moskowitz, the interesting part about this, of course, these are Bluetooth broadcast messages, and I would suspect that most phones are not listening to these except when they're in discovery mode. You have to have your phone go into discovery mode on Bluetooth to even be looking at these messages. Whether that then interrupts the use of your Bluetooth headphone at that time, to be able to do that, it depends on, again, how the radio code is designed on that. They go then into look at just the broadcast messages, and then do I even know what the zero have code to recognize? Oh, this is 0D type. Oh, I need to pass this up to the application that deals with that. That's the Open Drone ID code to be able to process these messages. So there's a lot of underlying hidden things here when you get and who will be actually doing a Bluetooth beaconing other than troublemakers who want to confuse what's available in this case and Wi-Fi NAND then produces yet another interesting set of concerns as a different media that's being used this. But if you get down, for those of you who live down these lower levels, have experienced these lower levels, it is, and Juan Carlos, because he deals with this, he knows a lot about this as well. It's a mess down there. But once that packet now gets passed up, it's a Bluetooth broadcast. It's a 0D type. It gets passed up to this application. It's then going to be making whatever decision it's going to be making. And then we have the some messages are single broadcast, the general ID, the vector information, but then it's the auth messages, which is a chain of these messages together, which then comes to the question, what if you got 4 out of 5 of them? And how to do forward error correction, a couple other things, but that's getting ourselves buried in the details, and this is above.
Yeah.
Carsten Bormann, what do you do when you have 500 out of 5? So I can tell you what my students will do when they read this document. They will write a thing that waits for the first page and then supplies alternate values for the other pages. So the receiver will have a lot of fun recombining these all and finding out which of the ones is actually the real one.
So I'll make an interesting comment on that to extend to it. So shout out to James at AX if he's listening. I don't see him on the Make Echo. But when we were developing our RID application, our demo prototype, we decided to try to make the phone a surrogate to a UAS because that was what we were doing initially. Turns out Android phones change the MAC address randomly when you send messages. The ASTM standard expects that the MAC address stays static because that's how they correlate to, what drone it came from. I won't go any further than that because we'll get into technical implementation details, but I just want to point that out because that is, I think, a similar vein.
Andrew McGregor. I'd just like to point out that there are some existing commonly used gadgets that use these features of Bluetooth from apps on both major phone OSs. So somehow it can be done. I don't happen to know how, but if you look into the remote control protocols for hearing aids, you'll find that they don't unbind as audio devices while they're in remote control mode, and the phone did go into discovery mode to get there. So, yeah, somehow it works.
Somehow, yes, I agree. So with that is my presentation. Any other questions, comments, concerns? Stu's walking up to the mic. Oh no. What did I do wrong?
Stu Card. So I just wanted to say what a vector message is. A vector message is a dot from the standpoint of surveillance and tracking. It is what is your position in 3-space and what is your velocity vector in 3-space. The other thing that I want to mention is this whole issue of going from 5 pages to 10. The ASTM standard already does 10-page authentication messages, but they fill 5 of the pages with stuff that they want to authenticate, and then the other 5 pages is for the signature or whatever. So we're not actually asking them to extend the total message length any longer than it currently is. We're merely asking them to allow fewer of the bytes to be used for the data to be authenticated and more of the bytes to be used for the authentication thereof, right? And the chairman of work item 65041 in ASTM, Gabriel Cox from Intel, has said that the 2 changes that we've asked for are no-brainers, and he expects them to be in version 1.1 if there is a version 1.1, and definitely in version 2.0. So simply getting them to accept the hierarchical hit as a UAS ID type, not a problem, and getting them to extend from 5-page to 10-page for authentication data, no problem. Now, somebody could stand up and object when it actually comes before the committee, but that's the opinion of the chairman at this point.
Okay.
Okay.
Okay, JavaScribe relaying from the Jabba. 2 things from Greg Deeds. The USS and deconfliction is key to adoption. And the trust framework is working on the ICAO identifier for the bird pilot. We're going to have a new unmanned and general aviation framework for the ID. Privacy is still a big topic of debate as who is flying over one's house, and your right to start and end as the person being flown over is a regulator issue, FAA, CAA, and will be coming next year as a rule from the regulator. We just got the F38.02 spec born, so we're working on it.
Fair enough.
Good.
100% agree. Wow.
Okay, so where are the blue sheets? We were passing them
on the floor because I just saw it go flying.
Anyone needs still to sign them? Okay, so please raise your hand and get them somehow.
So it'll take another 2 to 5 of your minutes just to give you, because we're at the hackathon, which was really fun. So this is what we did. This is XKCD 303, if anyone is not familiar with it. I had lots of fun. I was compiling things, and I waited. That's not what we really did, though. I did quite a bit of work. So OpenHIP is an implementation of HIP, obviously. I fixed it. Well, partially fixed it. It didn't really work that well in Ubuntu 18.04. There were some dependency issues and whatnot. So I made the builds go from 16.04 and did some manual work and fixed the make files. Hopefully this will make, HIP adoption and development a little bit easier. And this was something I've wanted to do for a while. So I'll be branching off in the Bitbucket and making a pull request soon. The next thing I did was I had a H-hit generation prototype. The source code was floating around the Tmrid list at one point. I don't know where it is now, other than in my possession. And I was using EDDSA 25519 key pairs for signing and verifying. I attempted to update to C-Shake instead of SHA-1. That's a pain. C-Shake hurts my brain. So, because there's no Python implementation, so I need to kind of review some stuff and do that. Then finally, the UAS demo application. If you were at the demo happy hour, we had a tablet, which I think is Stu's tablet, wherever it may be located, and my phone acting as the surrogate UAS and the receiver, and we were showing a very, very prototyped demo of what it's like when there's a hit as an ID type, and using DNS to look up information that the observer can see. There were similar demos done at the UAS test site. Shout out to James and Ryan at AX. They're the two that really have been fostering this implementation forward with me supporting them. And really want to shout out to James. He helped me remotely a couple of times where it was midnight in New York, and I emailed him, or I just texted him, and he answered me at midnight, 1 o'clock in the morning, even though it was 10 o'clock here, and he helped me out and debugged some problems for me and got me unstuck a couple of times. So huge shout out to him. So overall, it was super productive. I learned a lot of things, mainly that ACLs really suck if you don't know they exist or you forget they exist, and DHCP is not your friend when you're using ACLs, and C-Shake is a pain, so I need to figure that all out. And these are some next steps. Help is always appreciated, whether it's just supporting me through the mailing list or email. If you can help me out, that'd be great, or any of us out. And really more implementations are needed for interoperability testing. Any other questions or comments?
So one comment, which is, according to Google, there is a Python C-Shake now.
Oh, okay. Well,
I've not tested it. I haven't even downloaded it, but Google says there is one.
Download it.
Onto this machine. And something from relaying from Greg Deeds. Keep in mind that remote ID is also about avoiding collision with general aviators. That's why we need to have the big aviators work it out. We also need Apple to allow this beacon reception, which is not part of the IEEE Wi-Fi standard yet. Google phones do support it now.
You may take, yeah, go ahead. Like, I'm going to stop you. You're my boss.
So, Stu Card here. So I personally agree that UAS remote ID is a foundational technology for detect and avoid, vehicle to vehicle and vehicle to infrastructure communications, et cetera, et cetera, et cetera. However, the official party line at ASTM is that UAS RID is UAS RID, period, done. That it is not a component or subsystem for detect and avoid or anything else. Now, there is a reason for them to say that. Detect and avoid is a safety critical application, and UAS remote ID is being treated as a security critical application. And within ASTM, and I think within the FAA, Ray can correct me if I'm wrong, safety critical is regarded as a higher bar than security critical. And so if UAS RID is good enough to address security concerns, it may or may not be good enough to address safety critical concerns of detect and avoid for collision avoidance. So I just wanted to make sure that that was out there. That, you know, I may agree with the commenter on Jabber, right? But ASTM officially doesn't.
So response from Jabber. So agree it is possible in time. I'm not quite sure what that comment relates to, but and keep in mind that remote ID is about avoiding collision with general aviators. Thus, we need to have the big aviators work it out. We also need Apple to allow this beacon reception, which is not part of the IEEE Wi-Fi standard yet. This is the same message.
Yes, it is.
iPhone will only support Bluetooth 4.5 at 2 miles max, roughly. Google phones do support now. Samsung is coming next.
Yeah, there's a bit of fragmentation in the Bluetooth. It's surprising. My Pixel 4 supports everything for Bluetooth 5, which is quite surprising, including the long range. A lot of phones that say Bluetooth 5 don't actually support the long range. So there is that hurdle, but that's a technical hurdle that's beyond the IETF. I'll just make a shameless plug. I'm here all week. Find me, talk to me. I'd love to sit down, show you my draft, talk about the message formats and everything. So feel free to do so.
Thank you.
What is a beacon?
Okay.
I am a beacon. Oh, okay.
So now we're gonna go with Bob's presentation, and then I mean we are having quite many discussions anyway. I didn't want to cut them, so it's okay that it's taking a bit longer than planned.
Good morning. I'm Bob. A lot of you know me. I can assert that I'm Bob. though my sister calls me Robert. It is my classic in terms of talking about identities. When I was 11 years old, I got my first phone call from a classmate. Back in 61, getting a phone call was something. My classmate called, my younger sister, who was 7, picked up the phone. My classmate said, "Hello, is Bob there?" To my younger sister's response is, Bob, there's no Bob here. And she hung up the phone. So what's an ID? I've been basically thus lecturing about IDs since I've been 11 years old. Can I please have the other deck, the hierarchical hit? I want to do that one first.
Okay, good. So Bob, do you bring your bells today?
Yeah, I didn't come with my bells. I lost them somewhere along the way. Had to use them to get here. Okay.
Okay, there we go.
Okay. So, why hierarchical hits? What I'm doing here, the idea here is an implicit domain of use. I'm assuming there is knowledge of what a host identity tag is. But really quickly, a host identity tag is a hash of a public key into 96 bits with then 4 bits to add in terms of what is the public key algorithm, and then 28 bits in front of that, which is a valid IPv6 prefix. In other words, a hit is a valid IPv6 address. It's just not routable. Hierarchical hits is what I'm adding here is an implicit domain of use into it. And I'll get into the details of how that is done. The hierarchy information forms what the hit is for. The hierarchical hit associated with the hierarchy could prevent duplicate prevention, defense against hit hashing attacks because of how they be registered, and importantly, scalable lookups. Run the original hit work on distributed hash tables and how we could support large communities of lookups. But even though we had distributed hash tables, there came the question about distributed registration of them and who registers and controls that. It was problematic. There is an RFC out on distributed hash tables for hits. I'm trying to do better than that. But why hierarchical hits now? That was in the original design back in 2002. It was pulled out in 2003 because at that time there was no use case for it. Now there is a use case for it. The UAS could use national domains, for instance, FAA or other CAAs, providing the registry authority services. These are minimal to registering and signing the hierarchical hit, the HDAs, I forget, domain authority to this. The regional UTMs would then actually provide the domain authority services, such as their unmanned management systems. UA flying from Canada to the U.S. would be quickly identified as such, potentially because, this hierarchical hit was registered to the Canadian systems flying in the U.S. That may be perfectly okay or not okay, depending on the situation, or just maybe just launched in the U.S. That's a separate issue. But the point is that you can identify the domain in which it was registered. Each CA can apply its own policy on its UTMs and any other hierarchical HGA providers. So you can have different policies in terms of what needs to be registered, who has authority to get what this PI information, whatever they are, by doing this. There's not just in the distributed hash table, the flat one, there cannot be separate policies. This allows us to have separate policies. The UAA is free to register unique hierarchical hit with each region it operates in, or each day it operates, or each flight it takes, whatever is appropriate for its particular mission reality. So I had some design compromises. I had to stay within the V2 hit design, which is this 28-bit prefix, 4-bit identifier, 96-bit hash space. And what I worked out, so there's 96 bits for hierarchy and the high hash. I worked out that 64 bits is adequate for the high hash. There is math behind this. The draft gives the math, and if you want, I can even supply you with a Excel spreadsheet, which actually makes it very easy to plug in. But it shows us that if a domain has 66 million registered addresses, the next one coming in has a 100% chance of a collision. We actually generate 1 million hierarchical hits on a test, and there were no collisions in that 1 million we generated. We stopped after 1 million. Actually, I only asked Adam to do 1 million. I felt that was a reasonable request. Collision prevention through the hierarchical hit registration, which I'll be getting to in a bit. And I said in the draft, Appendix A gives the collision formula so you can work it out for yourself. As I said, 663 million is where you get to 1% collision risk. So it seemed reasonable. The 64 bits for the hash and 32 bits for the hierarchy. So what do I do with these 32 bits for hierarchy? Well, I decided to break it up into 2 levels for the registered assigning authority. Give them it's 14 bits. That means that solar system wide, there can be 16,384 RAAs. I felt that's a reasonable number of such entities. With each entity can then have in the 18 bits for the hierarchical hit domain authority. Each one can then just register 262,144 HDAs for each RAA. Again, I feel that is a reasonable number to have, and 2 levels of hierarchy seem to be enough for this management of the hierarchical of the devices that have hierarchical hits. So that's the decision I came up with. I'm open to other ways to play around with those 32 bits, but I took this as I explained to Stu, a stake in the ground, and a stake in the ground is a very, very strong statement. And if you want to apply it, I'll explain to you what a stake in the ground really means, or at least what it meant originally. But how are these top-level numbers assigned? That's a question to be answered. As with anything, when we create a new number space, who manages it? TBD. How to distinguish a flat space from the hierarchical hits? This becomes a problem. We're having to fit within the current flat space hierarchical hit. How can we tell which way to parse it? We have 2 choices. We can either have specific suite IDs for hierarchical hits in those 4 bits, or we can have a different prefix, different /28. So I recommend different prefixes because there are only a limited number of suites in 4 bits. We could potentially use the hit v1 prefix, except we know there are deployments of those, but they're probably not going to go away, and maybe we won't have collisions. So that is a question. That'll be answered by the people who own the prefix space. But it looks like that hopefully there'll be only 2 prefixes needed, one for flat and one for hierarchy. Thus, we need to get the hierarchy right, do it right the first time. Dirtfoot, in case you never heard the term dirtfoot. In my automotive history, it was always being said, do it right the first time. There's an impact on ORCA construction. Actually, there's 2 impacts on ORCA construction. There goes my glasses. Was designed for 96-bit hash of the high. There's no flexibility in that. No support for hierarchical bits. So this is a change to how ORCIDs are constructed right there. And additionally, though, it cannot take advantage of the new variable output hashes. Both Shake and C-Shake put out exactly how many bits you want. our tradition in hashes with using SHA-1, SHA-2, SHA-256, whatever, is we say, we got so many bits out, I need so many bits, hash it. Well, how do we hash it? Whole discussion on truncating it. How do we truncate a hash? With shake, it is a variable output. It is learn about, if you're all involved in hashes, look at sponge functions. They are, it's an amazing invention in the world of hashing. And we get out as many bits as you want. So this is a change to ORCID construction with this. So how should these changes to ORCID be addressed? Some are here, some of them in new crypto draft. Try keeping those, or am I going to create a separate draft, which is an addendum to ORCID? That's, again, organizational. That's for the working group to decide. But to note that right now I've been discussing this. I am changing ORCID construction for this work. The Python script soon to be available to create hierarchical hits for testing. We already have kind of one. The thing is we don't have the C-shake support for how we do the hashing right now, because that's why Adam has said that he needs a Python C-shake implementation so he can do it. And here comes Adam to speak to that.
Adam Whitaker, AX. So the original Python script that I ran the collision testing on was using SHA-1.
SHA-386, did you say not SHA-1? 384?
Yeah, 384. It's SHA,
384.
I'm using Python terminology, but I was using SHA-384 to do the collision testing, and then during the hackathon, I got the shake 128 to work because of the variable output length, but I didn't get C-shake because of the implementation problem. So I can have a Python script with either of those available to whoever wants one. I got to get it up somewhere at some point on a GitHub or whatnot, and I'll be working on that hopefully during the week. So I just wanted to clarify that point.
And just as a pointer, when I'm talking these hashes, these are NIST standards. Shake is in FIPS 202. C-shake is in Special Pub 800-185. And these are referenced in the documents, and they are available from the NIST site if you don't have them. So questions on the hierarchical hits? Okay, Jonathan?
Maybe I'm just not paying enough attention, but is there no worry about finding collisions, or is it like, do you assume that the hashes are generated truthfully? Like, could I not try and come up with, I find a drone, can I not try and clone it? You know, like trying 663 million hashes, that's what, 2-3 minutes computer time?
Yes, these are concerns. That's the next presentation on the registry. The registry will have the hierarchical hit and the high. So it is a first come, first serve basis. Jay's jumping into my next set of slides. And then, yes, when you're talking about 2519, there are issues in terms of that you can have, multiple public values for private. I forget. There's some issues there, which I'm covering in the security considerations on that. But the registry addresses these concerns.
Okay, thank you.
Andrew McGregor, I think it's probably just best to update the ORCID draft.
Excuse me?
It's probably just best to update the ORCID RFC or supersede it rather than spread it around amongst several documents.
I think that's what I need to do, is just spin it off and make that yet another draft.
Apart from anything else, that speeds up the process. To Jonathan's point, sure, you can clone. You can find something that matches that hit, but you're going to have a to run the protocol, you're going to have a valid, a matching private key. And yes, but what you can't do is get the registry to sign it, because they'll just refuse because it's a collision.
But I don't care. I just want to pretend to be someone else. And if the registry only has the hash.
Yes, but someone locally can look at it and go, hang on, that registry signature is invalid.
if the registry is signed the hash and hasn't signed the public key, then all I have to do is find another public key that hashes to the collision. And they will be, presumably, we're talking about signing the hashes, not signing the whole certificate.
It's signing the public key. That's why that thing is 200 bytes long, and what we have to do to get it to fit into the, I've not figured out how to make it significantly less than 200 bytes.
Yeah, one of the principles of HIP is that the tag is just a tag. You can actually make the protocol work using random tags that are not cryptographically bound to the public key, but that makes various things less efficient. So the hashing is an optimization here.
Will not make the claim that I've handled every single edge condition. I have tried really hard to get that done, and the registry is a key part of this whole thing. So let's go on to the registries. Hello? Beep. Come on, let's go. Hello?
Not responding, or okay,
Hello?
just
I got the battery here or something?
no, it's just the whole thing just froze.
Hey, there we
Okay,
go.
now it's
Okay. So this is a service provided by the Hierarchical Hit Domain Authority, the HDA, and also the RAs for the HDA itself. All hierarchical hits for a domain must be registered. Prevents duplicate hits, and the high is associated with the hierarchical hit, which allows us to deal with various attacks against them, hashing attacks. Collects other information based on the HDA's policy for other lookup based on who has authorization for that. The registries provide retrieval based on the hierarchical hit and authorization. Initially, what we're looking at is using RC 8005 DNS HIP resource record. This is what we were testing with. Stu provided the tablet. Adam provided the Android phone. I supplied the server that actually was running a version of Bind, where we're providing the domains and the lookups for this to show that we're retrieving the HIP resource record, using the hit and getting the high as a result. But other information, registry information based on authorization, and we're talking about what protocols that'll be because DNS has no authorization, so we have to do that in something else than DNS. Expansion to this draft is expansion to 8003, the registration extension. The registration of hierarchical hits is always authenticated. Know your clients. No support for opportunistic registration. It will be, you have to be able to prove who you are to be able to register. Because what you have to have something either using an X509 cert for your ID. Of course, that's a chicken and egg problem, or a pre-shared key. Again, where did this device get its pre-shared key? That can be done through some sideband. For instance, the device first tries to register because it has nothing. It fails. But in that registration says, no, send my PSK over to here. And it's very common what we see today in various web-based SMS sending of an authorization code method can be used. This needs a lot of work still. I won't say that I have that done. Again, getting into hits, some of the other things that can happen is that the I2 message in the registration can contain a CSR. So here is my hit to my high, and I'm going to need a certificate for being used for other sorts of things. And then the R2 can actually then contain the client's X509 cert, which then the client now has also a certificate, can use in any other applications to assert its clientness. There is a new parameter that I'm introducing, the client info for registry-specific information requests. This is just a blob, and it'll be defined by the HTA in terms of what information. Give me the operator's name, the operator's phone number, whatever other information that they may want for it, and whatever format this client info blob will be. And I'm making no attempt yet to find that. Now, the operation, how this works, starting from the top, the RA must have a hierarchical hit with an HDA value of 0. The HDAs must also have a hierarchical hit, and they register with the RAA. That says, I am now a valid HDA for this RAA. And the RA provides lookup service confirm that, yes, this HDA really did register with me. The RA may provide a PKI, going back to those certificates for the whole thing. Example, RC 802 for hits inserts. The hierarchical hit cert can be used to sign the HDA's client registrations and so forth. So we can have a parallel operation, the raw certificates, the raw hits for the efficiencies and the packets, but for those things that would love and say, I got to have X509 certs, we can do that. Or there's also work in codes for a concise object ID, and that may be yet another alternative for that work. So the RAs may provide other signed objects for a FDA validity. This gets back into what Adam was talking about as an example of them. The HDA can then use this in client hit registration. So again, this is proof of registration message, this 200 byte thing that I created that the clone can then, the drone can then provide this. The observer can say, yes, this is the HDA's proof of registration. Thus, I know that this drone's claim that it is registered with DHS is truthful and valid, and I can now assume that this is a DHS drone. This is a whatever other registry, and gives us that information. So that's kind of a fast run through. Read my drafts. I have it in there. The drafts are not long. Of course, they assume that you know a bit about HIP before you get into them. They're fairly short drafts that shows how this process works. And I believe that it then would allow us to have a trustable ID, which then can be used in the work that Adam is doing, and scalable authorities and protection against cloning, protection against false claims of identity, and have this trustable, actionable IDs.
Good. Questions?
I have one more set of slides.
Okay, so put the last deck. Yeah.
Yeah, my last deck. New crypto.
If you can keep it be concise, that'd be perfect.
I'll do this fast. Hello.
Is it not responding? Okay, so can you?
Okay, what's new is adding the EDDSA algorithms for highs and the new hash algorithms, which is SHA-3, Shake, C-Shake, and KMAC. These change everything in how we do things in HIP, and they're really, I'm really fascinated by them, what they change. And finally, a new AEAD. I'm using KAC as a placeholder, as NIST is still having the lightweight competition. I really like KAC for a lot of reasons, but I am not a cryptographer. I will not at all be involved in the decision-making process. I'm just a crypto plumber that uses this stuff. But the beauty about KAC over the other computers, it's the same code base as all the rest of as the hashes. So in terms of code savings, it's or FPGA implementation, it's using all the same stuff. This changes everything in HIP to crypto. Smaller, lighter, faster. EDDSA is defined in RFC 8032, only using the 255.19 and the 448, not using the pre-hash forms. I really don't like the fact they use SHA-512, and I've been given how to comment on, 165? Anyway, there's a standard, and this is coming out, which give me a place to comment about this, because this may be the only place the device may be needing to use the old SHA forms, because handling the 255.19. That's a side issue and outside of the use. The key here is small key size. Only 32 bytes for 25519 and 57 bytes for 448. Why 57, not 84? It's not called Goldilocks for nothing. If you all followed when the discussions, the rest of it, why was it called Goldilocks? Just enough crypto. Signatures are twice this size. So the public key is 32 bytes. The signature is 64 bytes. And that's what we're working with. There's nothing else out there of this size, which is reliably secure and usable. Curve 25519 and Curve 448, natural compression representation. This applies to EDDSA as well. No patent issues as with the NIST P256, which has the compressed format patent from Certicom. This is already specified in HIP-DEX, but that static there is high. This is now adding it as ephemeral Diffie-Hellman. Hashing of all manners. HIP uses hashes in many places in many ways. Ketcheck is a major change approach to hashing and has significant impact on many aspects of HIP. As I said, sponges are amazing things. If you want to learn about them, go to Ketcheck's site. Lots of documents out there. FIPS 202 itself has some very good details on how the sponges work. And 800-185 expands considerably on the variable outputs, as well as 56C-R1 on key material generation. And yet there's another one coming up soon. So Shake, Rattle, and Rock. Shake and its derivatives provide variable length output with known cryptographic strength. This is really something new in the area of hashes. Not a fixed length output, but a variable length output. Maybe we should it should have been called squeeze, because the concept is you put all your data into the sponge and then you squeeze out as many bits as you want. No more truncating hashes. No more debating about how to truncate the hashes. This is important impact, as I said, for ORCIDs. And instead of know which bits to select, an interesting ORCID takes the middle bits, other people take the front bits, some take the back bits. That's no longer an issue. Shake 128 for the R hash in HIP. Another significant change is using KMAC, which is another Shake variant. KMAC does in one sponge function, which HMAC needs 2 hashes. So there's no truncated needed for HIP MAC and HIP MAC 2. They are naturally, by using KMAC, you get the size you need. KMAC for the KeyMat production. And here's a really big one, and it amazes me, but I've got a lot of confirmation, and I really need the cryptographers to weigh into this one, because according to 56C1, you have one KMAC operation for what HMAC does. HMAC needs 2, HKDF. It does 2 HMAC operations for HKDF. And that's each 2 shell operations. So one sponge operation equals 4 hash operations and what we traditionally do. Jury's still on this construction. Only a couple of cryptographers have commented, but I seem to have it right, but it warrants more review. The lightweight AAD cipher. This is an active competition going on at NIST. No winner yet, but KAC is Ketcheck based and the same code base and FPRG implementation. It's a good for a starting point. I'll also be working on a draft for using it in ESP for additional cipher for ESP, and I am using it in HIP cipher. And finally, the PRF. No pudding today. So Appendix 185, Appendix B tells how you can use Shake as your PRF construction if you need that in your implementation. So I kind of ran through it. It is all new crypto coming in, but well-established crypto, and it does have input, and it's kind of like I find it interesting that nowhere else in IETF am I seeing discussion about the Ketcheck hashes.
So, Eric Nordmark, so trying to translate this to my not knowing any of this. So what are the benefits? Is it that we can get smaller signatures with the same level of security, or more like flexibility in terms of how big we make them?
Smaller, EDDSA, smaller signature, smaller public keys. The hashing, faster hashing, lighter weight code, and in the case of the macking and the key generation, fewer operations, less load on these small devices. Actually, we call them small devices. Remember, they're throwing a tremendous amount of power for their navigation, tremendous amount of power for their cameras. These are typically quite capable devices. But they're saying that, well, we don't want to waste any of our capability on crypto. Crypto's too expensive. We need it to keep the bird in the plane. So again, keeping it even small for this case is very important. So they'll say, oh, I guess I can afford to do this.
Okay, thanks.
More questions?
Yeah. Andrew McGregor, it's a bit rich to hear UAV people talking about crypto being too expensive when just the heat dissipation of the MOSFETs and their speed controllers exceeds the power consumption of the entire radio system and computer. But anyway.
Well, they're saying, but we need it for that.
Do you know of any formal analysis of the KMAC construction? I've just been looking on the Ketchak team page, and there's a bunch of people who've done practical cryptanalysis. But is there any reason we believe the construction itself is in any way secure?
I've been pointed various things. I don't know the things I've been pointed to answer that question. I am not the cryptographer in the room. I am the crypto plumber. I've been told that these things have been extensively evaluated. You can trust NIST as far as you can trust NIST to put them in NIST standards, but others are using it, and it is what it is. It is pretty amazing. I'm hoping that this will then drive more of this evaluation, because right now, where is it being used?
As far as I know, nowhere. Network time, NTP. But okay, it's fine. Could you, I don't know, put on the mailing list or something, a list of all the papers you've been pointed to, just for people like me to have a look at?
I will try to dig it all together. I've been talking with Johan Diamond in Belgium. Been speaking to him directly, and some of the others. Also in the past, in CFRG, we've had, I forget the gentleman's name who's attended a couple of the sessions. One of the other members with the monkey hash. They've been making their monkey 12 hash, so they've been here as well. And so they've told me a number of things about it. But yeah, I will dig through my emails to find out what I have there, and share those.
That'd be great. Thank you. Okay. Thank you. Okay, so thanks. This has been all the presentations, and we had good discussions, which is good. So now we're gonna move to thank you, Bob. The last part of the meeting, which is that Bob put together actually a charter proposal, which the idea is not to do a committee editing or something like that, obviously. So go to the materials page and you can get it there. We are projecting, but scrolling up and down is not gonna work for everyone. So it's online available. And the idea is with all the presentations, the problem space, the basically constraints, the initial approach that they are using to solve this, whether or not it's worth it, chartering a working group or rechartering the HIP working group. So that's the question we are having here. So please take a few seconds to read through it, and then we will move into the questions. Bob.
Just maybe one comment. If you go through the charter, is that the expectation is that the work is being driven in a pretty fast way. So take that into consideration as well.
There was one comment earlier in the BOF of a line which I will be adding in here, and that's liaisoning with other organizations.
Right.
Yeah, that's not in this draft. That will be in the final charter.
Yeah, I captured that in the notes. Yeah, good point.
Stuttgart here. So obviously there's a question of, do we take this on at all? And then if the answer is yes, that we take this on at all, there's the question of, do we recharter the HIP working group to add this scope, or do we create a new Tmrid working group? Because I don't think HIP is the end of the story in terms of application of various IETF standardized protocols to this problem space. I think we're going to need help in DNS, we're going to need help in RDAP, and who knows what all else. Last thing that I want to mention is, I know that a consideration is whether there will be available manpower to work this if we do take it on. And back at the ranch, we have Adam, James, Joe, Matt, Ryan, and Zevi. So, okay, six young developers, not counting me because I'm useless at this point. He's nodding yes. We have 6 young developers who are not focused exclusively on the remote ID problem, but they are focused exclusively on communications and networking for small UAS. And a big part of that is the remote ID problem specifically. So, and these guys are fully funded for like the next 18 months. So we have programmer cycles to work on prototype implementations for the necessary interoperability testing to move this forward on the standards track.
Okay, good. Thank you. Eric.
So Eric Nordmark, my question was going to be about the other pieces, right? Because I can see and people have presented, or Bob has presented the HIP part of things, right? But then the RDAP thing, because Stu, you were hinting earlier, maybe it's RDAP, maybe it's something like RDAP, right? And is that something that can be done later, or, because it's not in the list of deliverables right now, as I understand it?
Yeah. Bob, do you want to address that?
I'll address that. First, I want to address something that Stu said, and that is Stu's company that he works for has resources on this. Please, other people, join in and make it a broader effort. But now to Eric's comment, there's I got 2 lines in there talking about the RDAP, and maybe I need to expend more on interacting with other areas. And I welcome help on expanding the areas, because there is a need that we've alluded to here on how does the safety officer authenticate and get the PI they're allowed to get. Is this something that we're going to address in this work group, and how do we do it? What things do we need, or do we just profile something existing? So the work group, I think, will be needing to look at this and make a selection and minimally do a profile of how that is done.
Thank you, Bob. Andrew
McGregor. I think the HIP parts of that charter are reasonably complete and sensible. I think because we're noting that there are things to be done in other parts of the protocol stack, I think the charter's not sufficiently complete at this stage to know what the scope is. That said, it should probably be a working group of its own that is chartered to do further work on HIP, because the HIP working group is kind of long inactive at this point in time.
Yeah.
And if the scope is substantially different, it does also deserve a new name.
Adam Whitaker. I just want to make another point. For a working group thing, it's trustworthy multi-purpose remote ID. That's kind of what we're calling this. There are other places that remote ID that we need to be trustworthy could be applied in. It's something that we know that's there, and if we can get something there, I don't know what it looks like right now, but I know that I don't want to say the word, but IoT, because that's a very dangerous word to speak here, I think, because it's quite a big term and it has a lot of people involved in it. But IoT devices, and as Stu was saying, you have a thing in front of you, you want to ID it, and you want to trust it. I think that is a big piece of this, but I don't know how it fits overall.
Okay, thank you. Arnold, again, please keep your questions concise and comments.
But I guess there was one question that wasn't answered about RDAP. So is it time frame wise, can it be deferred for 6 months to work on those pieces, or do we need to put it up front because we need to get the complete sort of registration process that includes the HIP part of the registration and the registration of the other information into an RDAP-like thing, right? That's like, because it affects the charter, because if it doesn't need to be started now, we could say, okay, it will show up later, right? Not an immediate workout.
Yeah, Stuttgart here. I can't answer the question, but I can tell you what ASTM has done. ASTM says in their WK 65041 work item that a registry is essential, but defining how that registry will do its job is out of scope for this particular standard. This particular standard will address only, I'm talking about the ASTM standard, will address only how the identification is done. How you then use that ID that you have acquired to look up data was left for the diligent student. I think that is a major material omission that does need to be addressed. But if ASTM can punt it temporarily, we could punt it temporarily.
Okay, and we are cutting the line now. So Andrew
McGregor, forgotten your name, to the point about other areas than aviation.
Adam,
to Adam's point, I note that marine traffic control and transponder protocols and the like are based on the aviation ones and very, very similar. And well, marine autonomous water vehicles are a thing. And I have no idea who to contact in the protocol space for that. But having been involved in New Zealand's Coast Guard, I can probably find someone who does.
Thank you, Andrew.
Wes Herdeker, ISI. So one of the things that confused me about sort of how you're supposed to think about all of these little pieces that have been talked about in the past 2 hours, right? Some feel fairly straightforward. It's like we can just throw it over the wall to HIP and we can add it to their charter, and you know, then you can use those pieces for the much harder building blocks that, you know, related to aviation and identification with all of the problems and all of the, we need help in these 10 areas. It doesn't seem like an existing working group is going to be able to take on something that large without, you know, doubling their time or something like that. So it's almost like you guys have two different charters that you're talking about. One small and constrained, and one you have a scoping problem. So.
Okay, so yeah, the last few minutes we're gonna go through the questions, and then we will ask the AD if he needs more clarification or you know. So the first one is basically you know, the scenario we talked about, the scope. So is there support to form basically a working group? Let's assume that we are forming a new working group. As I said, you know, rechartering forming is really a detail at the end of the day. So first of all, and I'm gonna be taking hands, you know, for and against. So who thinks that they support, or who thinks that, you know, we should be forming a working group to follow this charter? Please, hand. All against? So for the note taker, which is me, that was strong support to form a working group. So well, the charter, as Bob said, I mean, this was kind of like a draft charter. You know, he will basically work with you know, the ADs and to basically complete it. And there were some comments that maybe needs to be divided into two working groups. So we will look into all that. So the second is you know, the community think that the problem statement is clear, well scoped, and solvable, and it would be useful to solve. So again, please ham if you think that's true. All against? Okay, so basically, I mean, my summary is that, you know, we need to work more on the scope and basically, you know, clarify a bit more.
I think it was clear from the discussion that the concern was only scope.
Yeah, exactly. There were discussions like, yeah, even how many working groups we would need, if there's a general problem versus the specific one. So we got all the questions, and I think we can work on something. And now, as you know, I mentioned before, and then Stu was following up on that, we need to basically, you know, get a feel of, you know, the level of commitment and the level of energy and the level of, you know, the number of cycles people are going to be able to spend on this. So the first one is like, who would be willing to review documents? And this is not a hand. Please raise your hands. Yeah, of course. I mean, writing, reviewing.
And can you confirm this on the mailing list, please? Thank you.
Yeah, but show of hands so that 1, 2, 3, 4, 5, 6, 7, 8. So around 8 people that are willing to review documents. And well, the editor, we said, we included in that. So it's 8 people willing to edit or review documents. And yeah, there's more questions or yeah, exactly. So the next well, the working group, I think we answered that question already. Yeah, so I think we have covered everything. So at this point, as I said, the summary is that there was strong support to form a working group, but we really need to work still on the scope mostly to basically scope it in a way that is not too much to chew for a working group, and then I saw the energy. I think it would be okay. Also, following up your comment that there's also people, working, let's say, back-end support, prototyping, writing code, which is actually very useful. Bob?
I would like to thank Gonzalo and Daniel for chairing the BOF. I like to point out these two gentlemen are swamped in the work in the IETF. So to note that we will hopefully will get a work group out of this. So if you want to either have experience as a chair and have cycles, or you want to get involved in this area, speak to the AD, speak to our BOF chairs.
Yeah, and this is actually a good point. So that we agreed to help with the BOF, but going forward we would need also people willing to chair and that put much more cycles on this. Stu.
My parting shot here. I really want to thank everybody who showed up today, and doubly thank anyone who chooses to assist us in this work. Not wishing to be melodramatic, I do have to say that in all seriousness, this can save a bunch of lives.
Thank you. And to conclude the meeting, I would like to ask Eric if you have something to add. You are happy? Any further questions?
No, first, thank you again for doing this, and thank you for Adam and Stu on this. Obviously, the charter is not ready to go. This is clear. We can do it, of course, over mailing list, getting something. And we do not need another BOF maybe to form the working group, so we can go more direct. Everything needs to be completed on the mailing list, I'm afraid, there. Yeah. But I'm quite positive, and I'm pretty happy to see big names here and people looking to work beyond ASTM, because that was my major concern, to be honest. So it's not a single company effort. That's broader.
Thank you, Eric. So the next step, we will continue working on the mailing list on the charter, and the meeting is adjourned. Thank you.